In today's lesson, we are going to look at solving triangles and applications. So we're going to be looking at more word problems with the right angle trig ratios that we've been dealing with. So some tips to think about when we're dealing with application questions, right? And as we mentioned in the lessons looking at the trig ratios, you want to label your hypotenuse, your opposite, and your adjacent first. You always want to label your sides because that will help us determine what ratio to use. And if we don't remember the ratios or the formulas for the ratios, a phrase or an acronym that you can use to remember is SOHCAHTOA, right? So SOH, CAH, and TOA, or SOHCAHTOA. This is an acronym that you will probably hear every time you learn trig, and you can use it to help you determine what ratios to use. We'll look at that in a second. But once you determine the ratios to use, right, there's three scenarios you're going to be dealing with. Either finding the missing piece on the bottom, which means we then switch and divide. You're finding the missing piece on top, which means you bring up and multiply. Or you're finding an angle and you do the inverse function. So those are basically the three scenarios that you're going to be dealing with. We've seen them over and over again when we dealt with the trig ratios individually. So you just have to remember that those are the three options when solving any type of application question with trig. So SOHCAHTOA, how it works. So we have our acronym, which is great. So we have these letters, but what does that mean? Well, SOH, SAW. So SOH refers to sine is opposite over hypotenuse. Or we can think sine of theta is opposite over hypotenuse. Right? So the letters in the acronym tell us the ratio and then the order of the sides. So for CAH, CAH, cosine of an angle is equal to the adjacent over hypotenuse. And now you can probably guess what TOA means. TOA is tan of an angle is equal to opposite, or O, over adjacent. Right, so again, really, the acronym just helps us determine what the ratio of sides are going to be, or what sides we're dealing with. So the first thing we want to do, or in this first example, all we're going to do is just go through and determine the correct trig ratio to use. Right? In the previous lessons, we knew what trig ratio to use because our lessons focused specifically on one of the ratios. But now we don't know what ratio to use. It's not a specific lesson. It's kind of, we need to determine what ratio we're going to use. So again, the first step is to label our sides. Across from 90 degrees is our hypotenuse. We have an angle here, a reference angle. So across from our reference angle is our opposite. And then our last side is the adjacent, or the side between the angle and 90 degrees is our adjacent. Now this is where we mentioned before in the previous lessons where you want to highlight what sides you're dealing with. So I need to find x, or that's what I'm being asked to find. So that means I'm dealing with the adjacent. Now the other side is going to be one of the sides, or the other side that I'm using is going to be one of the sides that has information. So in this case, it's going to be the opposite. I'm not using the hypotenuse because it doesn't give me any information. I'm not trying to solve for it. I don't know the side length, so I'm not going to be using it. So because we're dealing with adjacent and opposite, we have to go back and think what ratio deals with O and A. Well, that would be tan. So in this case, we would have tan of our angle, or I'm going to start off, we would say tan theta is equal to opposite over adjacent, O over A. And for this example, all we want to do is just make sure we can choose the correct ratio. We're not going to solve, we're just practicing going through and choosing the correct ratio. So in this case, we'd be using tan. For our next one, again, first step is label the sides. 50 is the hypotenuse, it's across from our angle, or from our 90-degree angle. We have our reference angle, or we're given an angle of 35. Across from that is our opposite, and then beside it is our adjacent. Now that we've labeled the sides, what sides are we dealing with? Well, we have the hypotenuse, we're given that information, and we're looking for x or the adjacent. So we need to be using a ratio that deals with a and h. And if we go back to our acronym, cosine of an angle is equal to adjacent over hypotenuse. So we're using the cosine ratio. And then again, we can go through, plug in our information, determine what value or what scenario it is, and go from there. But again, all we want to do in this is just determine what ratio. For C, again, going through the same steps. Our hypotenuse across from the 90 degrees, our unknown angle x here, but that's still going to be our reference angle. Across from that is our opposite, and then between that angle and our right angle is our adjacent, or the last remaining side. Now here, because we're trying to find an angle, we need to find two other sides, right? So we only have one missing variable or one missing thing from our ratio. Either the angle, which means we're given two sides, or one of the sides, which means we're given an angle and a side. So here I'm going to be dealing with O and H. Those are the only two sides I'm given. If I was given all three sides, you can just choose whichever two that you want, which means you can choose whichever ratio you want. But here I'm only given the opposite and the hypotenuse, so I have to use those two, and that would mean my O and H, which would mean I'm dealing with sine, because sine is opposite over hypotenuse. For D, again, label our sides. We have our hypotenuse. Based off our reference angle, we have our opposite, and then we have our adjacent. We're looking for an angle, but we're given the opposite and the adjacent, so O and A. The only ratio that deals with O and A is our tan ratio, opposite over adjacent. So that is the ratio that we will be using for if we had to solve this value, or for this angle. So all the steps that we were doing when we were determining the ratios, or when we were actually solving these problems in the previous lessons, we're using, again, now we're just putting in the added the added step of determining what ratio to use. But the labeling, our sides is all, and figuring out what sides we're dealing with is all things that we've done before. So again, last two examples of this, we're labeling our sides. So across from 90 degrees, we have our hypotenuse. Across from our reference angle is our opposite. And then the last remaining side has to be our adjacent. We're dealing with the hypotenuse. We're looking for the adjacent. So those are the two sides. So A and H, go back to our acronym or go back to the formulas. That should be cosine. So cosine of an angle is the adjacent over hypotenuse. Now, in this case, again, we don't have to worry too much about solving, right? But if you want extra practice in solving these equations, you can always go back and solve these for the missing value. And the last one, again, label hypotenuse across from 90 degrees, opposite across from our angle. Last remaining side is our adjacent. We have the hypotenuse. We're looking for the opposite. So O and H. So that means we are using our sine ratio. So again, that's just kind of to look at, can we determine what ratio to use? Because that's going to be very important that we use the correct one. Because that will determine whether we get the right answer or not if we use the right ratio for the sides that we're given. Now, in an application question, or just in a question in general, if we're asked to solve a triangle, right, what does that mean? Well, to solve a triangle means to find, I believe we might have talked about this already with similar triangles, but we want to find all sides and angles. So we want to make sure that we have every measurement for our triangle. So I want to solve this triangle here. So I have two missing sides, and I have one missing angle. Now, in some cases, we can use trig. In some cases, we can use other properties or other formulas that we've learned previously, mostly previously last year in grade 9. So I can actually find x right now by subtracting my other two angles from 180. Right? All three angles in a triangle add up to 180, so I can subtract 90 and 25. And if I subtract them, we get 65. So that means that this angle here is 65 degrees. So I found one piece of missing information. I've covered all the angles. The only thing left now are the two missing sides. So it doesn't really matter which one we solve for. We can pick whichever one. I'm going to solve for G. I'm going to solve for this angle, or this side length, sorry. So in order to solve for that side length, I need to use a trig ratio. Now I do have two angles that I can use as a reference, right? Because I need to label my sides. I know for sure that this is the hypotenuse because it is across from the 90-degree angle, but the opposite and the adjacent are going to be based off of my reference angle. So it's just a matter of whether I'm using the 25 or the 65. I'm going to use the 25 in this case because I know for sure that angle is right. Maybe for whatever reason I did a small calculation error and got the 65 wrong. Maybe it's not 65, it's something else, and I just made a mistake. If I use that angle in my ratio, then I'm going to definitely get the wrong answer if in fact that was the wrong angle. Now I know that is the correct angle. It's a simple calculation. I've done that. I did that on the calculator. I didn't do it in my head, so I'm confident that it is 65. So we just have to make sure, I'm just trying to eliminate all possible areas for error when going through and doing this. So I'm going to use the 25 degrees as my reference. So that means across from the 25 is the opposite, and that's the last remaining side is the adjacent. So in this case, I'm looking for the I have the hypotenuse. I need to use that side, and I'm looking for the adjacent. That's the one that I said I'm going to look for first. So in this case, A and H, I'm going to use cosine. So cosine of an angle is the adjacent over the hypotenuse. Sorry. We have cosine of an angle of cosine of 25 is equal to G over 13. Missing pieces on the bottom, or on the top, sorry, so we bring the bottom up and we multiply. So 13 times cosine 25 equals G. 13 times cosine 25 is 11.78, or we'll round to 12. So this is a measure of 12. That leaves me with the only other missing side is H. Now, there are two ways that we can actually solve for H. One, we can use, because it's a right angled triangle, we can use the sum of squares. And if I want to find the sum of squares for the leg, it's going to be that leg, or we'll say b squared is equal to c squared minus a squared. Or if you don't remember that, but you do remember the Pythagorean theorem, a squared plus b squared equals c squared. You could do that and then rearrange. So in this case, a and b are my legs. So 12 squared plus h squared equals 13 squared. I want to get h by itself, so I move the 12 over. So 13 squared minus 12 squared. We get 25, and to get h, we have to square root 25, which gives us 5. So that's one option, or we can use trig. So we can use trig based off of the sides that we labeled in the angle of 25, but now that we're dealing with the opposite, and we'll say the hypotenuse, right? Just because we're confident that the hypotenuse is correct. So opposite and hypotenuse is sine. So sine theta equals opposite over hypotenuse. Sine of 25 is equal to h over 13. Again, in this case, we bring the 13 up because the missing piece is on top. So we bring up and multiply. So 13 times sine 25 equals h. 5.5 equals h. So a little bit of a different answer here. So let's see if we did something wrong. 5, so 13 squared minus 12 squared. Is 25. Square root of 25 is 5. So where did we go wrong? Why did we get a different answer? Okay. I think I know where we went wrong. So the only reason why we got a slightly different answer is due to the rounding. Right, so the difference between these two the difference is due to rounding, because when we did 13 times cos 25, we had it as, so 13 times cos 25 is actually 11.782. We rounded it to 12. Right? So that difference, that change in answer, because we used 12 in the Pythagorean theorem, or the sum of squares, that's how we were able to get 5, whereas the sine ratio doesn't take that rounding into account. So that difference between our two answers is due to the fact that we rounded our side length to get 12. And so that's the only way we got the different answer. But again, you can use those two methods to find the other missing side if you wanted to. I guess it kind of just goes to show that you want to be careful with how much you round, because you can get two different answers. But as long as it says just solve, it doesn't give you specific ways. You can go through and solve either way. I would just highly recommend showing your work, right? Because that way I know what you did. I can verify that you did use the right answers, and it was just a matter of different signs, or sorry, just a matter of rounding errors. So moving on from solving triangles, we're going to be looking at application questions. So with application questions, there are some terms that may come into play that we might not have heard before, but they do relate to the angles in the triangles that we're going to be solving, or the scenarios we're going to be dealing with. So first we have our angle of elevation. So in this case, an angle of elevation is the angle between the horizontal, or a flat line, and the line of sight when looking up and at an object, or our line being rotated up. Right? So it doesn't always have to be a line of sight. It could be just using it as a reference to say from a horizontal, from a flat line, and then up to another line. That's our angle of elevation. So if we kind of draw it in here, this angle here going up, that's our angle of elevation. Angle of depression is a similar idea, except now instead of going up, we're going down. Right? You can think the term depression means you're feeling down. So similar idea. So in this case, it's from a horizontal and then down. So one thing to note, so it's from the horizontal line down. So it's this angle here that we just kind of drew in. It's not this angle. Right? So that's one thing you need to keep in mind. It's not that angle, right? From the line down to the vertical, it's from the horizontal down to the line, right? So there's two things you want to be careful of, because it is a common mistake to go from the line or the object, or from the line of sight down to the vertical, instead of from the horizontal to that line of sight. So let's look at some scenarios. Right? A missile is launched at an angle of elevation of, it shouldn't be 800, it should be 80 degrees. Because an angle of elevation of 800 does not quite make sense. And an angle of elevation of 80 degrees. If it travels in a straight line, what is its altitude when it hits the training drone 15 kilometers downrange? So with every scenario or application question, you're going to have to draw a triangle. And for our purposes right now, we know it's going to have to be a right angle triangle. Right, so if I go through and roughly draw this, right, we have a missile. It's being launched. Oops, not the best missile. So missile that's being launched. So we have a missile being launched, travels in a straight line. So we can already kind of see where our triangle is going to become. Now it hits a training drone. Let's see if I can draw a drone. So it hits a training drone downrange, and it is 15 kilometers downrange. So we're talking about a horizontal distance of 15 kilometers. Oops. And we want to figure out what is the height, what is the altitude. Right, so in this case, this height and the ground make a 90-degree angle. We can make that assumption. We also know that the angle of elevation for that missile, so from the horizontal up, is 80 degrees. So what we're going to do next, now that we have our triangle, let's go through and label our sides. Right, so we have our angle of elevation, this 80 degrees, which is going to be our reference. We have our 90-degree angle. So we can use those two angles to help us label. So we have our hypotenuse, we have our opposite, and we have our adjacent. The sides that we're going to be dealing with, well, we're looking for the opposite, so we need to use that. We're given the adjacent, so we need to use that for a piece of information. The hypotenuse, unfortunately, doesn't give us anything, so we're not going to use it. The ratio that deals with it is going to be, because we're dealing with O and A, we're going to be dealing with tan. So tan theta equals opposite over adjacent. And now I'm going to fill in my information, something that we didn't really have to do last time when in the first example. So tan of 80 is equal to an unknown, we can call it just x, over 15. In this case, the missing piece is on top, so I have to bring the bottom up and we multiply. So 15 times tan 80 is equal to x. And now we can just solve. So 15 times tan 80, and we get 85.1 equals x. So therefore, the drone is 85.1 kilometers high. So again, it's just taking our scenario, turning it into a triangle with the given information, and then solving for the missing piece. Our next example, a hot air balloon on the end of a taut 95-meter rope rises from its platform. Sam, who is in the basket, estimates that the angle of depression to the rope is 50 degrees. So let's draw this. Right. So we have a balloon. We have a hot air balloon. It is at the end of a taut rope that's risen from its platform, and it drifts off. So it's a taut rope. And we know that it's 95 meters long. He estimates that the angle of depression from the basket back to the platform where he anchored is going to be 50 degrees. So in this case, our horizontal and the angle of depression here, so let's put this 95 actually on the other side, is 50 degrees. Now we want to figure out how far horizontally did the balloon drift. Now there's two different ways you can think of this. One, you could think of this imaginary triangle on the top part of the rope, so a horizontal line coming across until it meets with a vertical line coming from the platform. The other way you could look at it is vertical line from the balloon to the ground and then across to the platform. Now, if you do use that, the second one that we just did here in blue, if you do use this one thing you have to keep in mind, that angle of 50 degrees, that angle of depression is not in this triangle. What you could assume though, is because these two lines would be parallel, then that means following our Z pattern, our 50-degree angle would actually be down here. Or I can solve for this missing angle here because it should form a 90 degrees because we have two kind of imaginary vertical and horizontal lines. So that makes this 90 minus 50, which is 40 degrees. So this would have to be 40 degrees. So we have two different triangles that we could use. We have two different angles that we could use for our references. It's just a matter of what we prefer. So I'm just going to redraw the triangle using which one of the information that I'm going to use. I'm going to use this triangle. Again, it doesn't really matter. I'm going to use my 50-degree angle though, using the Z pattern, because I want to use the angle that I'm given from the question. I have 95 meters, and I'm looking for how far did it drift. So based off of my angle that I'm dealing with, I have the, I can label the hypotenuse, I can label the opposite, and I'm looking for the adjacent. So in this case, the two sides I'm going to be dealing with are A and H, the adjacent and the hypotenuse. That would be cosine. So cosine of an angle is equal to, not opposite, adjacent over hypotenuse. So cosine of my angle of 50 is equal to x over 95. This one works out nicely because I can bring the bottom up and multiply. So 95 times cosine of 50 is going to equal x. When I do that calculation on my calculator, I get 61.1 equals x. So therefore it moved or drifted. So therefore it drifted 61.1 meters. Next, it's asking, how high is the balloon above the ground? So in this case, how high is the balloon above the ground? So we have to, again, I can draw the same triangle. 50 degrees, 95, my right angle, and 61.1. And now we're looking for, we're going to still label x. We're now looking for our other side. Because I'm using the same angle, it's going to be the same labeling, hypotenuse, adjacent, opposite. So in this case, we are dealing with now opposite for sure. Now we have our choice. We can choose to use the adjacent or the hypotenuse. It doesn't really matter which one we use. It's just going to change what ratio we deal with. I'm going to use the hypotenuse though, because the hypotenuse is the side that we were originally given. So just in case I did get my last side measurement wrong, I want to make sure that I'm not getting the answer, this answer wrong as well. So O and H, that is going to be sine. So sine theta equals opposite over hypotenuse. Sine of our angle, sine of 50 is equal to x over 95. Because that missing value is on top, I bring up and I multiply. So this works out to be a nice calculation. So 95 times sine 50, equals x. Again, just a calculation. And we get 72.77. Or we can say, just for keeping it to one decimal place, 72.8 equals x. So therefore, the balloon is 72.8 meters high. Lastly, viewed from the platform, the angle of elevation is, and we've kind of already dealt with that, right? Because of the triangles that we used at the beginning up here, we've already kind of dealt with that scenario, and we've already kind of determined what that angle of elevation is. But again, we'll just draw a quick diagram. So we got our balloon. We have our balloon. It's at the end of a taut rope, which is 95. We know the angle of depression from the horizontal is 50. That makes a right angle from the horizontal to the vertical of the platform. The angle of elevation would be from the horizontal of the platform and up. So down here, we already said the Z pattern would make this angle 50. Right? So because we're dealing with kind of parallel lines with the two horizontals, the ground and the imaginary horizontal line in the air, we have parallel lines. We can use the Z pattern to figure that out. So therefore, the angle of elevation is 50 degrees. So the same as the angle of depression. Our last example, a truck driver estimates that a country road rises 40 centimeters every 6 meters along the road. What is the angle of elevation of the road? So we have our country road and it's rising over a certain period of time. We want to figure out what is this angle of elevation down here. What is this angle? Now from our scenario, we know that it rises 40 centimeters for every 6 meters. Now, one thing to think about, we have two different units. So we need to do a conversion. We need to have the same units. Now, it's up to you what you want to convert it to. If you want to convert it all to meters or all to centimeters, I'm going to do all centimeters because I'd rather use whole numbers rather than some decimals, which I would get when I convert to centimeters. So rise is 40 centimeters. So that vertical is 40 centimeters for every 6 meters along the road, or 600 centimeters along the road for our horizontal. I'm trying to find this angle of elevation. So let's label our sides first. Our hypotenuse is across from 90 degrees. Our opposite is across from our angle, and our adjacent is between our angle and the 90 degrees. What sides are we dealing with? Well, we're looking for an angle. We're given the opposite. We're given the adjacent. We have nothing for the hypotenuse, so we can't really use that. So we're going to be dealing with O and A, which is tan. So tan theta equals opposite over adjacent. Plug in our information. Do the inverse to find our angle. So the inverse tan of 40 over 60, or sorry, 40 over 600, we should get the angle of elevation of 3.8 degrees. So therefore, the angle of elevation is 3.6 or 8, I can't remember, 3.8 degrees. So from this lesson, again, the main things are to focus on some of the steps that we looked at before. I'm going to scroll back to the kind of tips that we want to look at. So we want to make sure we can label our three sides. We looked at that multiple times in the previous lesson. So we want to make sure we can label properly based off of a reference angle. We are then going to determine what sides we're using or trying to find, because that will help us determine what ratio to use. To determine what ratio we're going to use, we can use SOHCAHTOA to help us remember the formulas. SOH is sine theta equals opposite over hypotenuse. Ka is cosine over adjacent, cosine of an angle is equal to adjacent over hypotenuse, CAH. And then TOA, TOA, is tan is equal to opposite over adjacent. So again, that acronym just helps us remember what our ratios are of our sides. And then once we plug our information in after we determine what ratio, we have three scenarios to look at. One, we are trying to find a side and the missing pieces on the bottom, so we switch and divide. Two, we're trying to find a side and the missing pieces on top, so we bring up and multiply. And again, finally, if we're finding an angle, we always use the inverse. So again, these are the main things we want to look at. If you're having trouble still solving the trig ratios in general, make sure you are going back and practicing, because you do need to know how to do that in order to solve these application questions.